I was talking to Jimmy Mesta. He's the CTO and co-founder of KSOC, and we were having a discussion around what was happening with this whole over 900,000, I think it was, Kubernetes APIs, released to the world, right? Like they were sitting literally public. And we were kind of discussing this, and we were also at the same time discussing his Kubernetes OWASP top 10 stuff. And he brought up this LinkedIn post to me, and I read it a few times, and I thought it was pretty interesting. And it's all around the idea of misconfigurations, essentially. So, like, what's happening on a compromised service account? Who has access? Is this a zero-day vulnerability? Is it not? Does it actually matter if the Kubernetes API is public? Maybe it does, maybe it doesn't. Kind of depends on what your RBAC policies are like, kind of depends on what's running in your environment, and if something were to get compromised in your environment, what it has access to. So let's kind of bring this full circle here and talk about the number one on the OWASP top 10 for Kubernetes, which is misconfigurations. So let's dive into this here a bit. Now, the first thing on the OWASP Kubernetes top 10 is misconfiguration. So what does a misconfiguration look like? Well, I think we all kind of know, but let's kind of think about what to keep in mind here from a Kubernetes perspective. First, don't run pods as root. Next, be careful with what service accounts have access. And I constantly see this. I think this is a humongous piece of this whole misconfiguration pie is, what are you giving your service accounts? When you're creating a cluster role and you're creating a cluster role binding and you're binding it to a service account, what is actually going on there? Do you even know in the back end, if you're installing maybe a third-party service, for example, what's actually happening? Now, the next piece is no privilege containers. And of course, always question your RBAC policies. Pop this open here for me. We're going to take a look at this and kind of see what's happening from a misconfiguration perspective. So going through this list here, we can go through the description, and it pretty much states that manifest misconfigurations are arguably one of the highest impact things that you can see from a security perspective. Now, I forget the exact number, but there was a Red Hat report that came out recently around Kubernetes, and I believe it was 93% of security issues in a Kubernetes cluster are due to misconfigurations. Now, Jimmy went ahead and he put together a solid list that you can think of. The first is application processes should not run as root. So we can see a configuration here that we don't want it to run as root. We want it to run as a user. Next, we want to ensure that there are read-only file systems that are in use. So we can see that when we're creating a pod here under our security context, we can ensure that there's only a read-only file system. And then of course, privileged containers. And what that essentially comes down to is the container can have access to other resources and kernel capabilities on the hosts that are running, so the worker nodes, control planes, etc. We want to make sure that that does not happen. And how can we do that? Well, we of course want to set our security context inside of our manifest. And again, I see a ton of Kubernetes manifests and I don't see this done enough. So you'll definitely want to do that. And the other piece of this, and this is a little bit more advanced, but definitely important from a security perspective, is to ensure that you have OPA or open policy agent policies, try to say that 10 times fast, inside of your environment. Now, OPA is pretty solid. You can use something called Gatekeeper, which is essentially a middleman between your Kubernetes cluster and OPA policies. And you can set up all of these configurations for your entire cluster. You don't have to worry about it strictly at the manifest level. So let's head over to a GitHub configuration, and I want to kind of show you the behind the scenes of what happens inside of these clusters sometimes. So I have Rancher pulled up here, and Rancher is definitely one of the most popular Kubernetes management tools out there. You can see logs, you can control your clusters, you can configure your clusters from Rancher, all of that good stuff. Now I'm in the installation piece of Rancher, and it's under Rancher/chart/templates. And what I'm going to do is I'm going to go to cluster role binding. And if we scroll down here, notice how I have a service account that's being attached to this cluster role binding. And this is for the installation of Rancher itself. And the role ref is specifically stating that I'm giving the service account that's installing and managing Rancher cluster admin access. Now, to me, this is a little intense. Perhaps this is needed for a Rancher to do everything that it needs to do inside of a Kubernetes cluster. I think that makes sense, right? If it's managing your entire Kubernetes cluster, it does need to have access to everything. However, this right here on line 13 is definitely a little bit scary from a security perspective. So, point being, when you're installing things like, other CRDs and other operators and service accounts and cluster roles and role bindings that are needed for a certain platform or tool or whatever you want to call it to run inside of your Kubernetes cluster, you always want to look at the YAML to see, okay, how is this configured? Is this considered a misconfiguration? If it is, how can we update it and fix it to meet our standards from a security perspective?